Okay, today not only is a special day because of our 200th episode, but it's going to be a tough day because we're trying to implement the last functionality, the last bit of functionality for our game in terms of movement. And it's a very tough problem to solve. I would be very happy if we could figure it out today. I am thinking that's probably not going to happen though, but I'll show you what the problem is. So yesterday we made it so that, see how this is a 13 stack? If we pick up an amount of stones and the only available move is a 13 stack, I have it so that we can't lock in having any more stones than we can place on that grid. But so I'm pressing enter, but it's not letting us lock in that amount of stones because it would crash if we were to place that on the only legal move. But if we have one stone, we can place one stone in a 13 stack, and that's legal because it's a 14 stack. But then if we go and it's black's turn, we can't pick it up because we're surrounded, and we're surrounded by a 13 stack or by a 14 stack. So the problem is, that's all good, well and good because it stopped us from crashing. But the real issue is that if we wanted to move over this 13 stack and we wanted to only drop in one stone into that grid, we should be able to. We should be able to pick up 5 stones from here, lock in 5 stones, and then be able to drop only one stone in the stack here, and then move over and drop another stone, move over, drop another stone if we wanted to. Basically because we can drop one stone in there without it crashing the game. And if it gets stuck, if we're stuck right here where you can't go over a stone stack like that, then this is effectively like a wall in the game. A 13 stack would effectively be like a wall where you can only add one more stone to it instead of just pass over it. So ideally we should add that functionality. It's just really, really tough because the whole fix we just implemented was to prevent an issue from happening here that we solved, but we have to basically unsolve it and resolve it in a more complicated way to also add in this factor of being able to what are you doing? What do you want? What? It's really tough. It's really tough. And it's even tougher if we were to put, for example, another 13 stack here. Because we technically would be able to, if we had a 13 stack here, pick up all 5 stones, drop one, drop the rest here. That should be a legal move. So I don't even know where to go about starting it, to be honest. It's very complicated. I think we start by taking a look at what we exactly do in a movement event 2 to check whether or not we can move our stones or not, because we need to add an exception. And the exception is we can pick up more than our lowest surrounding occupants if the next move after that has room for our occupants to be dumped. But it's even more complicated than that because we need to check the next grid and do the same function as a sort of, okay, we can carry more stones into that grid if the grid after that has space for the rest of our stones. Granted, it's not a standing stone blocking our way, a capstone's blocking our way, an off-grid blocking our way. It's very complicated. I don't know it. Part of me says just forget about it and move on. But then we'd be giving up. And this should be a legal move. We should be able to dump one stone here and pass over it. But there's so many factors to consider. Let me take a look at our movement event 2 and see what's going on. You know what? I'm gonna just minimize our functions here so I can navigate easier. This is definitely the most amount of functions we've ever written for one program. Oh, okay then. Okay, here we go. So here's all our movement events. Now we can kind of see easier what we're doing. So in a movement event 2, after we click to pick up our origin stone, actually, yeah, movement event 1 is just okay, this is where we click. Oh my god. Okay, so here, if enter's pressed, this is the logic we just did yesterday, where we're saying, hey, if our milestone occupants plus our lowest surrounding occupants is going to be equal to or less than a 14, meaning we don't pick up more stones than we can handle. Okay, so we would add something where we would say, okay, else if our mouse stones dot occupants plus our lowest surrounding occupants is greater than 14, then we need to do some checks. Because we still need to move to movement event 3 if and this is where it's complicated, because it's like we need to do this and we could just do an else here, but I'm just keeping it explicit so it's easier for me to read and navigate the code. So there is a scenario where we want to move to movement event 3 when we have more occupants than our lowest surrounding occupants. And that scenario is when the next grid, now in movement event 2, where we're locking in how many stones we have in our hand, and pressing enter. Okay, shit. This is even more complicated than I thought. Oh my god. Because this is before we even select our movement origin. We don't select our movement origin until where? Oh no, this is... Hold on a sec. No, yeah, we do select our movement origin and movement event 1. Okay, so that's... Hi, sweetie. What do you want? What do you want? What? You want cuddles? You want cuddles? Oh, hi, sweetie. What do you want? You want to step on my keyboard and write code? I don't know what you want, sweetie. Dude, I got a code. Okay. This is hard because we'd have to check every single direction and every single direction's next move for the amount of occupants and the stone control and or off-grid status. That's why it's so complicated. Oh, it's really tough. Because, yeah, we need to... Oh my god, because it's like we need to... It's so tough. It's so tough. Let me maybe see if I can illustrate what makes it so tough, and maybe that'll help me kind of wrap my head around it. So let's say our stack is directly in the middle. Well, we don't. What is it? 3, 3. So 3, 3. We have a stack. Now right up. I want to say we get a 13 stack. Oh my god, it's so tough. I know it's a tough problem. But to try to illustrate what makes it so tough is tricky. Because we're gonna have, let's say we have a 13 stack right above us. So a row of 2. We have a 13 stack right above us, but then right above that, we have a standing stone. But then, let's say to the right of us, we've got a 13 stack and a 14 stack. And then let's say to the left of us, we would have actually to the right of us, we would have a 13 stack followed by a capstone to the right of that. Or actually followed by nothing, because... Okay. So if we're looking at... Now this is actually technically impossible because this would be more stones than we even have. There's only 42 lay stones available. So 13 plus 13 plus 13. Actually, this is getting kind of close to being possible, but you wouldn't really see this in a game. But it doesn't mean a scenario similar to it couldn't exist. And this is just to kind of illustrate what makes it so tough. So right now, we're able to pick up, we should be able to pick up all 5, which we are actually not able to do. So this is a bug. Yeah, this is a bug. We should be able to pick up all 5 because we could dump all 5 to the left of us. It's blocking us because there's a 13 stack on all sides, which means we're only allowed to pick up 1. At which point it'll allow us to move here, but we should be able to move our whole stack over there. So we need to fix that first. Let me see if it says it's a legal move for us. It does say it's a legal move. Yet when we hit enter, actually curious why would it become not a legal move anymore? Oh, it doesn't. We're not even allowed to lock it in. So it's in our enter pressed. So we need to do something where we say if there's an empty space around us, go ahead and just let us pick up all the stack. So this is we can do another else if here. We can say how do we say if there is an empty stack next to us, any direction? It's an occupants of 0. Occupants of 0. Yeah. So we're going to say if any grid around our movement origin, and it gets so complicated because we can't just do arithmetic on our grid because we can be off grid at a grid of 6 or a grid of -1 or a grid of 0 actually. So we got to do our freaking corner cases, edge cases, middle cases again. But maybe we don't have to do that. Maybe we can say I don't know what to do. It's like we need a function called empty grid around us. And we just run this function here. And if there's an empty grid around us, we can go ahead and update our movement event. I'm really thinking I'm not going to be able to fix this problem. I mean, it's like, I'm pretty sure I could, but it's going to take me a ton of lines of code, I'm thinking, to do this, because to fix the real bug, not the bug we're trying to fix right now, but... So let's do this empty grid surrounding, which will be a... We gotta pass it in our movement origin. And we need to write this function. Yeah. So the reason we gotta write this function and we can't just say simple arithmetic is because the simple arithmetic, if we're at a corner, would index into a nil value in our occupants, which would crash the game. And or if we're at, any corner and we try to index all around, it'll crash. Same with the edge cases, and so we gotta kind of do this. Which kind of sucks, but so we would basically return true if there is an occupant on any side around us who's an occupant class whose occupants field be 0. Then we'd return true. So we need to do corner cases. We need to do edge cases. We need to do middle cases. So our corner case would be case would be if our origin row that we pass in is equal to 1, and we have a top left. So if this is 1 and our origin column is 1, that's a top left. We have a row of 1 and a column of 5. That's also a corner case. This would be a bottom left. This would be a bottom right. And we can do the else-ifs here because we're just checking every possible combination of this. No, hold on. If it is a corner case, it'll get caught by one of these else-ifs. Yeah. Oh my god, it's so much code, dude. It's so much code just to do a simple little thing. Okay. So we're gonna check if the grid to the right of us This is our top left, so we need to check right and below. So we're going to say if our origin row is the same, but our column +1 dot occupants field is equal to 0, then we're going to go ahead and return true. Now this function needs to return false otherwise. So it's almost like we need to return false at the very end in case it doesn't return true and break that loop. Wouldn't be a loop, it would be just an execution of this function, but okay, so that is to the right of us. Now we need to check below us. We would say if our origin row +1, same column, has an occupants field of 0, then we'd return true. Now we can combine these into one line. We can say if this is 0 or this is 0, go ahead and return true. Okay, this is our top right. Now for our top right, we need to check left of us and below us. So we'll say grid left of us, which would be the same row, column to the left. If that occupant field is 0, or this is the top left, this is left of us, we need below us, so we would say below us would be a row +1, the same column. If that is equal to 0 either, then we also need to return true. Okay, and then our bottom left, which means we need to check above us and to the right of us. Yeah, above and to the right, we would say if grid above us, which would be our origin row, -1, same column. If that occupants field is equal to 0, or if the grid that would be above us, we're looking to the right of us, if that occupants is 0 either, then we need to go ahead and return true. Now, bottom right, we need to check above us and to the left of us. Yeah, above us and to the left of us. So it would be the same as this. We can say if the grid above us or the grid to the left of us. Is an occupants of 0, then we'd go ahead and return true. Okay, so we've got our corner cases. This is like, what we're solving right now is like very simple compared to the real bug we're trying to fix. So it's making me want to not fix that other one. I mean, ideally, we won't really get a 14 stack. And you won't really get a 14 stack that you're going to move a stack over. Because stacks that high tend to get a capstone on them, and or a standing stone to kind of lock that stack. So maybe we get away with not implementing that passing over a max stack functionality, because I swear trying to think about how to do it would be you basically have to figure out from a movement origin lock, you have to figure out and ask all the possible directions and all the possible dumps in those directions, not only making sure it's not nil, but making sure that each space would technically have space for any amount of stack in your hand to be placed in every direction. So like, and for multiple spaces, like for the next move and next move and next move, because you can move 4 times. So technically you could move a 5 stack over 3 13 stacks, given that each subsequent stack has room for the rest of your stones. But we don't know what direction is locked in at that point, because you haven't actually selected your first movement at that point. Because the way we designed it, you pick up all 5 right at once. Which means we'd have to do the math to determine all possible moves in every possible direction upon a stone lock in a movement 2, and it's just too much. Ideally, we would have, ideally there's no stack limit and we wouldn't have to even worry about this, but since it's a 3D game rendered 2D, we just run into some problems that shouldn't necessarily be there. So I think I'm okay skipping that functionality, especially considering all the games I looked at, even on a 6x6 grid, they didn't seem to have more than a 12 stack. So I think our 14 stack limit on a 5x5 grid is probably going to be fine. And then we can move on to Joust sooner, because I swear to God, this is going to be very, very complicated, not only to write, but to debug and make sure it's working correctly. It's going to break a lot of things, I feel like. So on one hand, we're kind of giving up on that, but on the other hand, it's a limitation of our design where we knew we're making a 3D game into 2D, so we knew there's going to be limitations. So we're just trying to minimize the amount of headache we're doing, because it's really just a limitation of the 2D aspect of it that we're forced to do this implementation of it. It just makes it way complicated. Anyway, let's finish this. Let's finish this function at least. So we can, hi Rosie. So we can at least make a legal move when we're surrounded by an empty spot, which should be the case. So edge cases. Hi sweetie. Now our edge cases is gonna be if our origin row is greater than, this is going to be top edge, so we're going to say if our top edge, or if our origin row is greater than a 1 and our origin row is smaller than a 5, now this isn't exactly right. If our origin row is greater than 1 and our origin row is smaller than 5, this is our left side, actually. Let me take a look at how we do our edge case here. Okay, that's a better way to do it. So I'm just gonna snag this top edge case code because it's the same thing. Oh my god. Okay. So we're checking first, be like, hey, if our row is 1, then we know we're in the top edge, but our column cannot be equal to 1 and cannot be equal to 5 to be our 3 middle top edge cases. Then we need to say, this is top edge. Here's our bottom edge case. Now, ideally, we would pair these two functions. Well, I don't like muddying those functions together. I would say since we're already checking the top edge cases, we'd go ahead and check this while we're at it. But so if our row's 5 and our column's not 1 or 5, this would be bottom edge. So here's our left edge case. We need our right edge. Okay. Okay, so we need to check for no occupants in 3 scenarios in this case. And it would be, for our top edge, we need to do left, bottom, right. For our bottom edge, we would need to check left, up, right. For our left edge, we need to check up, right, down. For our left edge, for our right edge, we need to check up and left and down. Hold on, top edge, no. Okay, top edge, we need to check left, bottom, right. Instead of bottom, I would say down. And then bottom edge would be left, up, and right. Left edge would be up, right, down. Right edge would be up, left, down. Okay. Okay. There's got to be a better way to do this, but I'm really not knowing what that way would be. So let's check left of us. Say if grid to the left of us has an occupants that is 0, or if the one below us, which would be our row plus 1, same column, has an occupants that is equal to 0. Or if the right of us, so grid, same row, column over, has an occupants equal to 0. If any of those are true, then we're going to go ahead and return true. Okay, there's top edge, bottom edge. We need to check left of us, so it'll be same row, but a column to the left of us. We need to check above us, which would be our grid. Above us would be a row higher, same column. Then we need to the right of us, which would be same row, but a column to the right. I think. To the right of us, yeah. Okay, we need to check above us. To the right of us. And beneath us. Right edge, we need to check above us. We need to check to the left of us. Beneath us. I'm gonna say grid. Origin row +1 would be beneath us. Same column. Okay, those are our edge cases. Now we need our middle cases. Our middle cases are going to be if our origin row is greater than 1 and origin row is smaller than 5 and origin column is greater than 1 and origin column smaller than 5, then we're middle case. And if we're middle case, we need to check every grid around us. So we'll put this probably on two if statements just so it doesn't go so far off the page. We'll say if grid, let's do left of us. So origin row to an origin column -1 would be left of us if that occupants is equal to 0. Or above us, grid. Yeah, we can't do a nested if loop here. It'll mess things up, so we have to do it all in one line, I think. If our grid left of us is 0, if the grid above us is a 0, or if the grid to the right of us would be equal to 0, or if the grid beneath us, which would be an origin row plus a 1 at the same origin column. So those are all the possible scenarios. But then we need to say, if none of those are true, then we go ahead and return a false. So if we did this right, we already wrote the code for when we use it, which is upon an enter press in a movement event 2, I believe. Nope. Yep. Empty grid surrounding function, we're passing in our movement origin row, movement origin column, which will then return true if we have any surrounding occupants equal to 0, and return false if not. So we will update our movement event 3 in a case where we have enter being pressed and there's nothing surrounding us. So now when we press enter, it should actually lock it in and only this move should be available, which it's rendering every move as available. Where do we... Oh, here, we need to falsify. We need to falsify any legal move, just like we did up here. Okay, pressing enter gives us the ability to move only in the spot that can hold all 5 of our stones. Whereas if we have 1 stone in our hand and we lock it in, we can move it anywhere. So now that's looking like it's working right. Now, is there a way we don't have to copy and paste the same exact code here, depending on enter being pressed? But the thing is, we kind of have to we have to do it, out or inside these loops, because there's a scenario where we don't want it to become false if enter's pressed, and that's if there's no legal moves. Hold on. I'm gonna keep it like that because we don't want to falsify the legal moves if we're surrounded by stones. If the current amount of stones in our hand is going to be bigger than 14 on any surrounding occupants, we don't want to falsify those legal moves just yet, because we don't have a way of retruthifying them in case we change our mind about how many stones we lock in. So I don't know. I think that's okay. Okay. Well, I think now would be a good time. We can, for now, turn off our debugging and instead add some instructions for what to do on which turn of your move it is, and then we can go ahead and try to do a real game. I can play against myself and try to do a game from start to end, minus the win state, of course, because we haven't done that yet. But then we can do that and see if we run into any bugs and crashes, and then if we do, we can kind of assess and try to fix those. But if we can get through a whole game without crashing, then once we add the win state correctly, that'll be the game. So I'm gonna get me a drink real quick, and then we're gonna do that. We're gonna put some instructions, help. Yeah, we're gonna take off all this, and we're instead going to render out what you're supposed to do in which movement event. So if it's a movement event 0, it's gonna say click an empty spot to place your stone. If it's a movement event 1, it's gonna say select a stack in your control. Then movement event 2, use up and down to drop or pick up stones. Enter to lock in amount of stones in your hand, and then so on and so forth. I'm gonna give me a drink and I'll be right back. Watching the cats and dogs. I'm watching cats and dogs. I blow my nose. So we're going to go ahead and remove our debugging. Obi wants to go out. As soon as I let Obi out, he pooped outside as soon as he got outside. So we're gonna go ahead turn off these debugging. So we're gonna just do this. We're gonna go ahead and turn this off too. Not gonna point what move type it is. Actually, maybe we should. Now, I'm curious to see if these font we put in here, if we make a tiny font here, I'm curious if we could do a 30-point SPQR font and have it look okay. Hey, Rosie, that is not your food. That's dog food. Okay. So yeah, let's just try to print out anything at this 30-point font that we just made and see if that looks okay. We're gonna just say love.graphics print. We're gonna print this is a test, and we're gonna print it at this X and this Y, just to I gotta let Obi back in. So I'm printing this as a test in our new lower font and seeing how that looks. And it would be green, which we actually don't want to do. We'd want to set, actually no, it should be white, which is what we want. Okay, it is still green, so it doesn't look like it's our SPQR font, so we need to set our font, set our color. Because yeah, we're setting it to green up here. Okay, yeah. So we're gonna set our color to be equal to white, which should be everything. 255. Love.graphics.set font to our actual instruction font. Nice. Now this this SPQR font doesn't look good that small, and we don't want to change the font of our other stuff. So we have this small font. So let's just manually change these things to be our small font. Okay. And then also, when we print up our player here, we want this to be a small font too. Nice. So I'm going to move this move type place to be down here for the whites move. With that as white, then we'll make our SPQR font just a bit bigger, and that'll be our instructions. So let's move our this is the Y of what we need our move type place to be, and our move type place is right here, so we'll give it this new Y, and our X will be whatever this plus however long this is. So maybe 150. Maybe we'll start it at 150 and see if that's left enough or right enough. Nope, needs to be over more, so maybe 350. And we also need to set our color to be white. Okay, it still needs to be over just a bit, because if you look at right here, they overlap. So it's white's move and then move type, so maybe another 50 pixels. Yeah, actually I'm gonna give it more space because I don't want it to overlap like that. Or let's just say, I want it to be kind of right justified with the edge of the grid there, which now it's a little too far. Okay, nice. Nice. So let's enlarge our instruction font just a bit. Just want it to look crisp. It's not a good font. That's not a good font for what we're trying to do. It's just all caps and looks bad. It's good for TAC. TAC looks great in that font, but we'll just use our small font here. So let's get rid of this instruction font. We'll just use our small font. We can replace it with a better looking font later if we want. So let's scoot over our X, maybe 50 pixels. Okay, that's fine. Cool. So this will be our instructions. Now, we need to only print out certain instructions depending on our movement event. So if we're a movement event 0, we're in a move type place. So we would go ahead and say, now I want these to be constants here. So I'm just going to put this as our instruction X constant. And then our instruction, we want we'll set our instruction y to be initially this 250, and then we'll have an instruction y increment that we'll have to figure out the value of. But instruction y offset here gets maybe 50 pixels, I don't know. We'll have to see. So let us put those constants here now. We'll say instruction x, instruction y. Yeah, that should work. And if it's a movement event 0, we're going to go ahead and say click to place your stone in an empty grid. And let's see if that's working. Yeah, it goes off screen, so. It's almost like we need an even smaller font for this. Let's do a smaller font. We'll give ourselves an even smaller font here. And now it should be smaller. Cool. Maybe a bit too small, but I just don't want to have to do new lines for any and everything. Okay, so let's move our X to be further to the left. Okay, just about. Okay, click to place your stone in an empty grid. Now, if we're in a move type move, nothing should print there. Cool. But yeah. Cool. Now we should also probably add like something like if, or hit up or down, arrow up or arrow down to switch to move type move. So we also want to print arrow up or down to move a stack instead. Yes. Now we want this to be added with our y offset. So y plus our offset here. Now instruction y offset is a nil value. Instruction y, because I spelled this wrong. Instruction y offset. Here we go. And we'll see if that offset is okay or not. Cool. Arrow up or down to move a stack instead. Cool. Cool. So there's our movement event 0 instructions. Now we've got to print out other stuff. Move an event 1. So if it's a move an event 1, then we're going to print other instructions. Those other instructions for move an event 1 would be select a stack in your control. Select a stack you want to move. Select a stack in your control that you want to move. Now that's probably going to get off the side of the screen here. Select a stack in your control that you want to move. So let's put that you want to move on another line. So we'll just really interested in making this as pretty as possible. Just interested in making it work. Then we can worry about making it look pretty. Select a stack in your control that you want to move. Cool. Maybe we say click to select. Click to select a stack in your control. Click to select a stack in your control that you want to move. Cool. Now, move an event 3, or move an event 2, is it? Would be arrow key to drop and pick up. So we'll say here, else if move an event is 2, we're going to say something like amount of stones that you want to move. Now we'll put instruction X in our instruction Y here. Now why did our Y move there? It did not. Okay, whatever. Arrow up or down to select the amount of stones that you want to move. Then beneath that, we'll say press enter to lock it in. we'll say press enter to lock in. Press enter to lock in amount of to select arrow up or down to select amount of stones that you want to move. Press enter to lock in that amount. Press enter to lock in your hand. Does that make sense? Now we're going to do this, and we're going to do this times 2. So click to select a stack in your control that you want to move. Okay. Arrow up or down to select amount of stones that you want to move. Okay. Press enter to lock in your hand. Cool. Then it'll be now we're going to say this is actually select grid you want to move to. Click to select grid you want to move to. So let's say we wanted to move this one. We enter lock in our hand. Click to select green grid that you want to move to. It gets off here. Now there's something right here. If we only pick up one stone, we need to advance our movement event. So we should do that. So this is movement event 1, movement event 2. Now, if by the time we pick up, we need to do this where we need to say, instead of arrow ring up or down to select amount of stones you want to move, if we only pick up one thing, we just need to skip. So if we're in a movement event 2, let's go to our movement event 2 logic. If we're in a movement event 2, we also want to go to a movement event 3 right away if our mouse stones dot occupants is equal to 1, meaning we only picked up one stone, then we don't need to select how many stones we want to move. We just need to move to a movement event 3 where we select which grid to move it to. So that should fix that problem. Let's see. Now, if we pick up a stone that's only 1, it goes automatically to placement. So that's a little more user-friendly now. And click to select a grid that you want to move to. Let's see if that fits. Nope. Click to select a grid. going to go ahead and move this to another line. Click to select a green grid that you want to move to. Now, we're actually not, at some point in time, okay, never mind. I think we should instead, right now, we're rendering a light green, but we should render a dark green, just to signify the difference between our movement origin, because once we click on it, it turns green anyway, but when we click on it, it should just stay there. So I think it should be a dark green grid in our movement event here. This is movement event 1, movement event 2, movement event 3. So movement event 3, instead of doing our locked in highlight, movement event 3, let's go. Movement event 3. Okay, instead of a legal move highlight, we want to do our, what is it? Move locked highlight. Is that right? That's red. This one's red, this one's bright green, this one should be dark green. Why do we have 2 here? Oh God, I don't know why we have this. It's not so much the legal move highlight that we want. It's the darker green one that we want here. So instead of legal move highlight, I think we want move locked highlight. So let's go ahead and say that this is move locked highlight. Okay. Nice. Now it's that darker green. So now it's select the green grid, just to help differentiate, like, maybe we should even change this brighter green to something else, but nice. Let's keep going. We're on movement event what? Movement event 3. We just finished movement event 3. So on movement event 4, we need to say what? Arrow up and down to select amount of stones you want to dump. Arrow up or down to select amount of stones that you want to place. And then we can say press enter. Press enter to press enter to continue. What do we want to say there? It's like to place. Press enter to place. Press enter to. Maybe we just say press enter to. Press enter to lock in the amount of stones placed. I don't freaking know. Press enter to lock in amount of stones dropped, yes. And then every other subsequent move event is basically the same. So if move event is greater than or equal to 4, then we're gonna go ahead and print that last value there. And I think we might be good. Nice. Cool. Nice. Okay, so we've got our instructions on screen now. I'm gonna see. I kind of want to play some of the music I got on here. We've got a lute track that I ripped from YouTube, but I'm hoping if we play it at quite enough volume, we don't get tagged or anything. But we're gonna go ahead. Yeah, I want to set the volume of this to be quiet, so let's see. So it looks like we can do a music : set volume to be a value between 0 and 1. So maybe we do like a 0.2, set volume to 0.2 or something. So it just plays a little bit. Maybe. And we give it a shot. Yeah. Okay. Okay, so now what I want to do, I've got to go to work. Shoot, I've got to go to work in less than 30 minutes. So let's hope we can do a game in less than 30 minutes, and we'll turn this off. So we'll start with a clean slate, and then we'll play ourselves our first ever tech game. Okay. Now we should also add where in tack the first player gets to place the other person's stone and the other person gets to place the other person's stone. So I'm going to go ahead and place each other's stones in the corner because that's probably what a game would normally be like. Now the game, you're trying to make a stack across, you're trying to make a road of your stones across. Now, only lay stones and capstones count as the road, standing stones do not. So I'm gonna just kind of now white is going to actually move on top of black, taking control there. And black is going to say, I don't care. White's going to be like, well, I'm going to get me a little bit of a threat going. Black's like, I don't care, I'm almost winning. Black is almost winning here, but it needs to go all the way across the board. So white is going to be like, you know what, I'm going to actually take your stone here. And black's going to be like, you know what, be right here. White's going to be like, I don't care, I'll go on top of you. Black's going to be like, I don't care, I'll be right here. White's going to be like, I don't care, I'll go on top of you. Black's going to be like, I don't care, I go right here. This is fun, I'm having fun. So black's turn, I keep up the threat. Now white can actually just take this and gobble up this whole space. Still has control, just gobble up that whole space. And then white is almost winning here, so maybe black is gonna say, I'm gonna block you right there. White's gonna say, I'm here. Black's gonna say, okay, well, I'll eat you here. And then white's gonna say, well, I've got a 5-stack here. Black's gonna say, I'm gonna gobble you up here. And then, this is cool. You know what? White is gonna say, you know what? I'm putting my capstone here. Black's gonna say, you know what? I'm putting my capstone. Actually, not yet, not yet. But it'll put there. Oh, you know what? We need to add a feature. Yeah, we need to add a feature. Now, a standing stone can actually go on top of a standing stone. A capstone can go on top of a standing stone and crush it into a lay stone. So we need to add that functionality, which is really important. It's something we forgot, but that's why we're playing this game now, trying to figure it out. And so far, no crashes, which is nice. Now, how do we have so many more? Yeah, we've got a lot more blacks on board than whites, I think. But okay. Since we can't crush a capstone, that's kind of a huge deal, so we can't really play a true game just yet, but this is fun, and we're trying to get somewhere here. So now white's one square from winning, because this counts as road, this counts as road, and it goes across. So if white puts one stone here, then they've got a road. Black doesn't want to give up control here, so maybe they'll put standing stone here. But yeah, since we can't crush standing stones, we can't really play to the full extent, but we're close. Now white is really close to winning here. Black is kind of on the run. Now black could just put a standing stone here, but since we can't crush it, I'm just gonna say we actually move our stone here, and actually that gives white the win here. Boom. So white has got a road going from the left side of the board to the right side of the board. So white would win. We don't have our win state yet, but that's cool. I'm gonna say we're just gonna move some stones around and place some stones so that and like this, if all stones are occupied, we shouldn't be in a move type place. So let me add that to our notes here. If all grids are occupied, default to move type place, and then we need to add cap stone crush. For standing stones, that's huge. We forgot about that. But I'm wanting to see if we run out of spaces here. You leave him alone, Obi. So player one is white. So white and black are almost out of stones. Now player one is out of stones to place, which means they can only move, so we've got that down. And then if black is out of moves too, we're only in a move type move. And we actually want to turn the cursor on, I'm pretty sure, because otherwise you can't see what you're highlighting over. But yeah, we're only in a move type move because we're out of stones to place. So cool, that's awesome. We're almost there. So yeah, we need to add capstone crushing functionality. We need to default swap us to a move type move if there are no empty spaces. Then we need to add our win state, and then we're basically done. Yeah, I'm deciding against doing our 14 stone function update to pass over, even though it's technically legal. I don't think it's going to come up in gameplay enough to justify the amount of work it's going to take me to do it, because it's a very complex problem, and it's only won through a limitation of trying to do a 2D game of a 3D game. So I think I'm okay with that. I want to keep on, like, I want to be able to finish projects and move on and keep building new projects. And I've already been working on this project for a couple months. So I think it's time we wrap up this project and then get back to Joust and finish Joust. Then we can start our brand new game, which will be fun. But tomorrow we'll try to start implementing that capstone crush. And then once we fix that other bug, we'll be on to, we'll probably play a full game again, see if we crash anywhere, which it's looking good so far. We haven't crashed, but it's hard to say what would cause a crash because we really don't know. Could be moving from a stone in your corner that could cause a crash. You know, who knows, because there's different cases. So we'll do that, and then we'll have to figure out how to write an algorithm to determine that this would be a win for white because it goes all the way across the board. So that's going to be tricky, but that should be fun. Yeah. Thanks for watching our 200th episode. We're almost done with TAC, which is going to be awesome to get back to Joust and dive back in and finalize that, because we're really close to being done with Joust. We just wanted to take a little break, and we ended up taking a 3-month break with TAC, so it's going to take us a little while to get comfortable with Joust again, but it'll be good. I'm going to go ahead and get diffs. Let's just take a look. We added some new font stuffs, playing the music. We should probably turn the music off. We added a new empty grid surrounding function with a bunch of lines of code. We fixed a bug in our movement event 3. We added another case to our movement event 3, fixed another bug, and then we printed up all of our instructions. So quite a big update today. I'm gonna take our sound off actually. And then commit. Okay, so let's commit this bad boy, and then I gotta get to work. Okay. Uh-oh. What did I do there? I don't know what this one is. Okay, I don't know what that one is. But we'll add everything with a commit message saying added. That one I don't think started there until shoot, I don't know what I did there. What's this +1 stopped? I don't know what I did there. But we're gonna see. I don't know what that one is. What is this one? Remote host identification has changed. Oh God, I don't know what this means. Oh God. What? pressed something other than Control C, and then I got that weird error. So I don't know what I did that fucked that up. Remote host identification has changed. Oh, it looks like they just did this. Remove the old key by running this command. Add the correct host key in SSH. I don't know how to do this, man. Oh God, I gotta get to work soon. Okay, we won't get commit just yet. I'll figure this out. Figure out how to get commit this before the end of the day, but I gotta get dressed for work and get going for that. So I'll catch you guys tomorrow and we'll get that new functionality going.